Hi everybody. So today, the other day, everybody, well not everybody, 85% of people voted for exam revision. So that's what we're doing today. This is a COMP1511 revision session, not right now. There's one this afternoon at 2:30 to 4:30. It's run by CSE SOC. It's not officially run by our course though, but it's about our course, so it might be really helpful. I haven't screened all the questions or anything, but it's probably going to be helpful. If you can go to that, if you're looking for more revision. I think I said before that we were having revision sessions next week. They're actually in week 11. So the course run ones will be in week 11, and you'll get registration details soon on Ed Forum. Okay. Who's already done my experience? Has anyone already filled it in? Oh, so I haven't looked at the statistics, but we want to get, a high percentage of people filling it in if possible. So please do that. Also, just be mindful that when you're doing my experience, we want, positive and negative feedback, but try and make sure it's respectful and constructive for all of the, you're also doing it for tutors as well, I believe. So just, you can be constructive. All right. And let me know as we go if there's any questions, of course. So has anybody booked in for week 10 practice exams? So if you're in an online tutorial, it's a very good idea. I really recommend that you book some tickets to go to a face-to-face lab class next week. Because this is your chance to log into the exam environment and see exactly what's available. So I can tell you about it, but I find that students really don't understand until they're sitting and they're logged in exactly what it will be like. So definitely go and book tickets for that if you're normally in an online tutorial. Okay, so when you go to the practice exam next week, I just want to give you a warning in advance. You're in a special exam environment and a special exam account. So you're not going to have all your files there, and that's the same as the exam. You're not going to have all your files there. You're going to have a directory that just has the files needed for the exam. But the thing is, you're also, like when you leave the exam, you're not going to have access to those files either. So if you go and do this practice exam, the files that you modify or the code you write during the practice exam, you can't access that later. You're not going to see, any marking or auto test or submission history. Okay, so sometimes people get a bit confused about that. That's normal. Once you log out, that's gone. It's for your experience only. The questions will be available on the course website for you to do at home. The big difference is you won't be getting the experience of the exam account. So don't worry if you go to that practice exam and you don't get to finish all the questions and you want to work on them again, that's fine. You'll be able to do the whole thing, as many times as you like at home for practice and revision. Any questions about that? Okay. All right, so last lecture we did a bigger linked list example where we did an email management system. We looked a little bit more at deleting nodes. Today, if we've got time, we'll finish some stuff we didn't finish last lecture, but I'm just going to focus on some exam information, making sure you understand what to expect in the exam. Also do a little bit of exam revision. We'll look at some hurdle questions. And then next week we'll do just even more revision. We'll go through revision for the whole course basically. So if you've got questions about the exam, get ready to ask them today. Code link as normal. So everyone always asks what's in the exam, but basically everything we've learnt. So we've learnt everything now. The last examinable topic was linked lists. So you're still practicing that and working on it, but we're not giving you any more new topics or content. So obviously, to do any kind of program, you're going to need to know the basics like ints and doubles and chars and structs. You're going to have to know if statements and while loops. So it's hard to imagine having any sort of questions in the exam that aren't going to contain some of those things. Then some questions will be focused on arrays. You might have some 2D arrays. There might be questions with strings. Obviously, there's definitely going to be linked list questions because it's a hurdle for at least COMP1511 students, and they have pointers in them. There might be other questions where we're specifically looking at pointers as well. So basically, all the topics we've done so far. You should all know by now that it's, I hope I've got this right, the 25th of November, right? Okay. You'll get 3 hours of typing time and 10 minutes of reading time in the exam, okay? So make sure you do use that reading time wisely. What do people usually use the reading time for? Do you think of it as wasted time where you can't type? Yeah?
Use it to realize which questions you're going to struggle with and then come back to those last.
Brianna just said you use the time to read through the questions, realize which ones you're going to struggle with, and come back to those last. Yeah, it's a really good idea to get the ones that you know really well out of the way and done. Give you confidence, know you've got those marks handled already. Okay, yeah. Yeah, budget your time. So we'll do more tips later, but yeah, I have seen people like trying to debug something and losing track of time and just sticking on one question and the next thing the exam's nearly over because they're just trying to find this one bug. So, we'll talk more about these sorts of strategies as well. Now, there's going to be 2 sessions of the exam. At this point in time, you likely don't know which session you're in yet, right? You'll be able to choose your preference. I'll show you the form to do that. But this is important. The way we run the exam, the students who are in the afternoon exam, they'll be going to a room somewhere. You'll be told exactly where you need to go, and you'll be corralled. So you'll be sitting in a room because we'll be waiting for the people in the actual labs from the morning session to finish their exam. We need to clear all of them out. We need to restart, you know, the lab environment again. And we don't want people crossing paths and, you know, giving people unfair advantages by giving them tips about what they had in their exam or, you know, anything like that. So you do have to get to the exams on time, don't forget. But especially if you're in the afternoon session, I think there's like a 10-minute, if you're more than 10 minutes late, I think you're locked out. So please get there on time, know where you're going. In the morning students aren't allowed to leave the exam early. So even if you finish early, now most people nobody just completes the whole exam early. That just doesn't happen. Sometimes people think, I can't do any more, I want to leave. Unfortunately, in the morning you can't. So if that happens to you, just keep trying, keep working on the questions for the whole time. All right, and you should hopefully know when these sessions are. Now, there's a form available now where you can register your preferences. So if you're a student that has another exam on the same day, you'd automatically be put in the time slot that, you know, won't give you a clash. Otherwise, you get to choose your preference. If you get in earlier, you have a better chance of getting what your preference is. So it's not guaranteed, but this is your chance to try and choose the one you want. Okay, so that just opened this morning. All right. Any questions about that? And then you'll get information about exactly where you need to go once all your time slots are confirmed. All right. So the practice exam, which we're running in the lab next week, which can only be done in the face-to-face labs, like in the exam environment, this test environment will be basically the same as the exam environment. So you can familiarise yourself with the setup. There'll be DCC, of course. There'll be auto tests. There'll be submit, which is like give, and you'll be able to submit your questions as many times as you like, and we'll mark the last submission, just like with labs. So that part will be very familiar. It'll be in an environment that's very similar to VLab, but there won't be as many features. Like, you won't be connected to the internet, you know, you won't be able to play videos of the lecture. Not that you'd want to do that in the middle of the exam, I would hope. You know, there are things, it's a restricted environment. You won't have all your customized things set up that, I don't know what you have in your own accounts. It'll just be a very, you know, basic setup. And there won't be DCC help, DCC Sidekick, or auto test help. So these are tools that we hope have helped you as you're learning to code. And then once you're in the exam, those tools won't be there. You'll still have DCC telling you what your compiler errors are, and you'll still have DCC telling you what your runtime errors are. You just can't get that extra help. Yep.
Do you have a cheat sheet?
Yeah, you'll have access to those cheat sheets that are on the website. You'll actually have access to the whole course website, but like a static copy of it. So you'll have access to the tutorial questions. You don't have access to tutorial answers now, but you'll have access to the lab questions, lab solutions, lecture code, lecture slides, those links that we have to, you know, see cheat sheets and stuff on the course website. Yep.
Will we be judged based on the comments as well, like in assignment?
Okay, so the question was, will we be judged based on our comments? No. Yeah, so I'll talk about that later when we mark it, but no, you don't get marks for comments. Yeah. And you know what, another thing that definitely won't be in the exam is, can anyone guess, in the exam environment? ChatGPT. So if you've been ChatGPTing a little bit too much, now's the time to stop and make sure that you're not over-relying on it, okay? And it's also the time to stop in terms of the assignment. We did find, look, compared to how many students we have in the course, the percentage wasn't that high, to be honest, but we did find people that use ChatGPT and who ended up with similar assignments to other people who'd also used ChatGPT for large chunks of the assignment. So please don't do that for assignment 2, because you can get flagged and caught, but also too, you're not going to have that in the exam. So you're robbing yourself of the chance to get used to those error messages and work out how to debug, have that, I guess you get used to that pressure of trying to fix something and then believing that you can do it, which you're going to need in the exam. All right, so I've said that already. Now, even though you've got access to the website in the exam, that doesn't mean there's no exam conditions, right? Sometimes people just, for some reason, think there's no exam conditions. So once you get into that room, you're not allowed to speak to other students. If you've got any issues, you can put your hand up and talk to the invigilator, like the supervisor. So if you've got any issue to do with your health, any issue to do with, you think one of the questions has a typo or one of the auto tests is wrong, or you think your mouse is broken or something like that, put your hand up and get help straight away with an invigilator. Don't accidentally ask the person sitting next to you, I don't think my mouse is working, what should I do? Don't do that, because that's considered exam misconduct. Just be very careful that you don't do stuff like that, either accidentally or on purpose, right? Obviously, you're not meant to be discussing anything. This is not a pair programming exercise, it's a final exam. So don't talk to other students. Even afterwards, don't get straight on Reddit and post your whole solution to one of the questions. That's also considered misconduct as well. So what can you bring in? You can bring in a clear bottle of water, so where we can see what's inside it. I don't know what you might put inside it, but that's the university rule. You can bring some pens in, because we will give you a sheet of paper, because we want to encourage you to sort of draw diagrams when you're problem solving, especially linked list diagrams. You can't bring your own paper in. We'll give you a sheet. Put your hand up if you want more. That's fine. You can get more paper. You obviously can't have devices or phones. So they don't just have to be off, they have to not be on you. You can't have them on you. They have to be in your bag at the front of the room. You can't have a phone on you, or a device like a fancy watch that's really like a computer kind of thing on your wrist. Or headphones. You can't have headphones or earplugs or anything like that unless you've got some kind of medical condition or documentation saying that you have special permission to do so. Okay. So when you come into the room and sit, wait for the instructions. So if you go to a paper and pen exam, you don't sit down straight away and turn the exam paper over and start, right? You wait until they say you may start the exam. Please do this. Don't just start logging in. Again, that's considered, not the right thing to do. And start, that's going to be bad. So wait to be told to start. When you log in, all the code that you need for your questions, you don't have to fetch it. It'll just be there. If you type ls, you'll see it. If you type in code to run VS Code, you'll be able to open it. It'll be in that directory. If you, for some reason, delete something important that you need, or, I don't know, destroy it in some way, you can refetch those pieces of code. So the best way to really understand all of this is to go to the practice exam and see what it's like next week. All right. So these are just some official exam rules, not specific to this course, but there's a fit to sit policy. So when you turn up on the day of the exam and do the exam, you're kind of saying, I'm well enough to do the exam. So if you turn up, sit through the whole exam, and then afterwards put in a special consideration form saying, I actually had a headache the whole time, I need to do a supplementary exam, the special considerations unit is going to say no. Okay, so if you are sick, for your own sake, stay home and rest and get better. For your own sake, don't come in and do a worse job because you're sick. and for everybody else's sake, don't spread your germs, because everyone's got lots of exams, and even the invigilators often have their own exams too. We all need to keep each other safe, stay home. Now, sometimes you might think you're okay, you get into the exam and you have some unforeseen illness or medical problem that comes up. In that case, again, put your hand up straight away. If you sit through the whole exam with it and then claim special consideration later, you'll get a no. If you put your hand up, let the invigilator know. Number one, we can help you. If you've got a serious medical issue, you may need some assistance. So put your hand up, let us know straight away. Then there's also documentation. You can leave the exam, rest, go to the doctors, get a certificate, and then you can put in special consideration. If you do it afterwards and sit through the whole exam, they're going to say no. So just keep that in mind. I know people get stressed and think, I better just sit here and keep doing it. I don't know what to say, I'm scared. Just put your hand up and let someone know, okay? So that's really important. Now, if you didn't come to the exam because you were sick, or there was some sort of accident or something unforeseen, or you did fall sick in the middle of the exam with a medical problem that was documented, and you put in a special consideration form, you might be granted a supplementary exam. So you don't get the supplementary exam just because, I don't know, you failed, but you tried really hard, unfortunately, or you just failed or anything like that. It's run by a centralised unit that makes decisions that are fair for everybody. So, you can't have a really kind lecturer going, okay, you can do the sup, but somebody else has a sort of stricter one going, no sup for you. It's centralised. So it's based on you having special consideration. And it will be in January, likely January the 21st. And there's more exam rules here. I'll move on to our exam now. All right, so does everyone know what a hurdle is and what a hurdle means? So in the course, if you're doing COMP1511, there's 2 hurdles. If you're doing COMP1911, there's 1 hurdle. But a hurdle is you need to pass the hurdle to pass the course. So even if you get over 50% in the course overall, if you fail one of your hurdles, then you can't pass the course. Okay, is everyone clear on that? Now, there's an array hurdle question, and the array hurdle is for everybody, 1911 and 1511. So there are 2 questions. You've got 2 opportunities to pass the hurdle. So to pass the array hurdle, you've got to get 50% in one of those questions. Not both of them, just one of them, at least one of them. So you've got to get at least 50% in either question 2 or 4 to pass the array hurdle. For linked lists, there's 2 hurdles, there's 2 opportunities as well. You can either get 50% plus in question 1 and or question 3. You don't have to remember the numbers of these questions. It'll be clearly marked on the paper. For 1911 students, the linked list won't be a hurdle for you, but you'll still be doing all those questions just to get marks in the exam. All right, any questions about the hurdles? Yep.
Now it's probably a good time to remind students that 50% means in auto marking, not in your auto test that we provide you.
Yeah, so that's a good point, Brianna. 50% doesn't mean you got 5 out of the 10 auto tests correct, right? Because the auto tests don't actually count for marks. The auto tests will be a guide for the marker to see what your code does and doesn't do. They'll all be marked by a human. So the auto tests are a guide for you to see how well things are working, what's passing and failing. They're a guide for our markers to see what's passing and failing. They are not a determinant of your mark. Yep?
Do we have style considerations in the exam?
No. So yeah, I'll talk more about that later. There's no style mark associated with the code that you give in. Yep, question? Yeah, you can copy and paste. From the what? You should be able to copy and paste from anywhere. Yeah.
I think he's referring to like using like your code examples and copying the examples from.
Oh, right. Yeah, you can. You can copy and paste code. We're not going to give you a question that has exactly the same code that you're given in class. You know, we're not going to say do the exact same question you did in lab 10 or something like that, unfortunately. But yeah, there might be some things you might copy and paste and modify. Okay, that's okay. It's not considered plagiarism if it's part of the provided stuff that you've been given in the exam. Yeah. All right. What's the exam format? It's all practical programming questions. So there's no theory or short answer or anything like that. It's all going to be coding, basically. We rate them. So you can, like in the labs, they've all got 1, 2, 3 ratings. That's to give you an indication of, you know, the level of difficulty we expect it to be. And like in the labs, sometimes maybe you don't agree with us 100% about the 1 and 2 ratings, I'm not sure, but they're a guide. So honestly, most people won't finish all the 11 questions. So question 11 is always designed to be a challenge question. If you get up to it, it's going to be quite difficult. You may not get up to it depending on how fast you are at coding. So don't sit there. If you come out and you think, I didn't finish the whole exam, that's going to be really normal. Unless you're aiming to get 99 in the course and come first, then you might need to worry if you didn't finish question 11. But you can get really good marks without finishing the whole exam. So we hope that most people should be able to attempt and complete the first 8 questions. There shouldn't be anything that's too surprising in there. Question 9, we hope many students can complete that. Once we get to question 10, there'll be less people and even fewer for question 11. This is not to scare you as much as just see, to make you actually not be scared in the exam if you're running out of time and you haven't finished question 11. Okay, yep.
Is there anything more difficult on 3 dots, like a 4 dot or something?
Yeah, question 11, we call it 4 dot or 3 dot plus skull. So look, usually there's not many people that get 11 out. It's really a challenge sort of extension thing because you've also got to do the whole rest of the exam before you even get to question 11, you know? So don't worry about that. Don't worry about it. So look, it's out of 100. So the first 4 questions are hurdle questions. So there'll be 2 linked list and 2 array hurdle opportunities in those questions. They're worth 12 marks each. And they're basically 1 dot hurdles and 2 dot hurdles. Question 5 to 8, they're debugging questions. So you've had a few of those in labs where you're given some code, it's supposed to do something, and there's bugs in it and you've got to fix it. So there'll be 4 questions like that. Unlike the labs, there's not going to be like a run-through video or something with them. And these are 1 dot questions. So there are about 6 1 dot questions in the exam. So I think it gives everybody a good opportunity to pass the exam. Then we've got some 2 dots, and then we've got some, 2 3 dots and a 4 dot. So yeah, we hope most people can do questions 1 to 8. All right. Yeah, questions are similar in, question?
In the labs, we get like what the sample output should be of our code. Are we going to get the same thing in the exam?
Yeah, the question was in the labs we get the sample output. Yeah, you're going to get that kind of style of question, a description. Here's the expected output if you run it like this with these examples. Some auto tests. And just like the labs, I think sometimes you might have to write a whole program. Sometimes you'll be given code and you're just writing 1 function. So there'll be a mixture of just writing 1 function. I mean, you can always write your extra helper functions or writing a whole program. There'll be some of each, but they'll all have that kind of, we expect this output. Because there's always auto marking involved, as well as human, but for auto marking, you really need to know the exact, precise definition of what you're doing. So each of your questions, you need to either write code or correct code, compile it, test it, give it. All of the questions will have auto tests. In the last harder questions, we might have less auto tests and there's more focus on you testing it yourself. The earlier questions, we're going to provide sort of more comprehensive auto tests. All right. All right, questions 1 and 2. So these are the two one-dot hurdles. So the first question will be a linked list hurdle, and typically it's a 1.1, so it's just going to be integers or doubles. It's not going to be some fancy linked list with all sorts of stuff going on in it, just a basic linked list. You're not going to have to change the structure of the linked list, like insert or delete stuff. So it'll be sort of traversing 1 or 2 linked lists, computing something, comparing something, something like that. So we hope everyone's able to do that. Question 2 is the one-dot array hurdle. So you might get like a one-dimensional array of integers or doubles or structs. You're not going to get something like, for that question, a two-dimensional array or an array of strings or something that's trickier. Not for that one. And again, these ones are just really testing your ability to use variables, basics like printf or scanf maybe, and use if statements and while loops through those arrays and linked lists. Okay, so I think everybody will be capable of, if they're putting in the work, of getting these questions out. I mean, it's always stressful in an exam, but these, hopefully with some practice throughout the term, everyone will be capable of putting in a good effort on these. Yep. Oh, you're just stretching. So this is kind of an example. We'll go through and code up these examples later. But, you know, the first linked list hurdle might be something like this. This isn't the exact question, but the sort of style of it. Like, given a function like this, you're given a linked list, find the largest value in that linked list, for example. Or sometimes you're given 2 linked lists. Here, you're asked to find the difference in the number of nodes in each list. Okay, sometimes you're given 2 linked lists and you've got to compare things at the same sort of corresponding nodes. You'll see something like that in the practice exam. So who's feeling okay about those hurdle questions? Just looking at those two. Who's feeling okay? All right, most people are sort of saying they feel okay. All right. Array hurdle. So hands up who's okay with structs. Hands up who's feeling confident with structs in general now. I know at the beginning most people were like, oh my goodness, what are these structs? Okay. So for the array hurdles, yeah, sometimes they could be an array of structs. Sometimes they might be an array of ints, something like that. So here's an example of a struct one. So you might have an array of like simple structs like this. Struct direction with 2 fields, an int and a char. And maybe you've got, the question is to go through and look through that array and find all the ones where the direction is L, right? So I don't know what I've done with this slide. You might be going through the structs and looking for that direction field, checking if it's L. If it's L, you're adding up that number field. So something like that. You're doing a comparison and a calculation. All right, the other type of, and these are all the sort of first, these are all examples of the sort of easy linked list and easy array hurdles. The other type you might get is array count multiples, where you're looking through an array of integers of a particular size, and here it just says count the number of multiples of 3 in the array. Okay, so these are the sort of first level hurdles. Now, if you could do both of these questions, like there were 2 versions of each, but if you could do one of those linked list ones and one of these, then you've passed the hurdle for the exam, okay? And you've gotten, like, if you've got full marks in them, you've gotten already 24 marks in the exam if you've done one of each of those. So that's not so bad, right? Or is it? I don't know. Question 3 and 4, they'll be the 2-dot hurdles. I don't have examples of those right now. A great place to find examples will be in the practice exam to sort of show you the sorts of things you might expect. But these are going to be a little bit harder than those 1-dot hurdles. But you don't necessarily need to pass these if you pass the other ones. Of course, it's an exam, so you want to get as many marks on as many of the questions as you can. So with these, they're just a bit harder. They maybe with the linked list, you've got to remove nodes or insert nodes, which is always a bit trickier. Maybe the array is a 2D array. It might just be that you've got to keep track of more different things. It's just going to be a bit harder. But it's still going to be basic things that shouldn't be a surprise to you. All right, then the debugging ones, we've seen, I've got no examples here, but they're like 1-dot debuggings, similar to what you've seen in labs. And you'll see some examples in the practice exam too. Questions 9 and 10, they're going to be 3-dot questions. So question 9 will be a sort of harder array question or an array of strings kind of question or a string question, something like that. Question 9, and it'll be a 3-dot one. Question 10 will be basically a 3-dot linked list thing. So again, you might be working with more complicated linked lists with more complicated data in them. You might be working with more than one. You might have to work out exactly what you need to do yourself. You might be given a problem that you need to problem solve with. But again, there shouldn't be anything in there that's a real super surprise that you've never seen anything like before. Then there's question 11, which again, this is just really for the people wanting to come, get 95, get 99, or just, just super keen and can't wait to do it maybe. Is anyone super keen and not able to wait to try this question? So anything could be there in this. You're probably going to have to break it down and do problem solving. It is going to be a difficult question. If you don't get up to it, if you don't do it, it's fine. You can still get a high distinction in the course, even if you don't do this question. You could definitely pass, get credits, get distinctions. All right, any questions? Yep. I think with the skull questions in the labs, I think they're all of different difficulty levels, really, aren't they? Like, they're very difficult. But again, a good point of reference will be the practice exam. So you'll see a full exam and you'll get a better feel for what could be in there. Now, last term on Reddit after the exam, people did get on and say, oh, they fooled us. They gave us a really easy practice exam and the real exam was so much harder. Now, we're not trying to fool anyone on purpose by making this easier than the actual exam. People will generally find sitting for an exam under exam sort of stress and pressure will make it feel harder than what it is. And sometimes what you think is harder might be different. Like you might have really wanted an array of integers, but you've got an array of structs, or the other way around. You hate strings. I don't know. So it's not purposely there to fool you. We're trying to give you a good indication, but Do we want to code or hear more about the exam? All right, we'll talk more about the exam and we'll do coding after the break. So pretty much all the exam will have auto marking. But we'll also have humans marking the questions as well, okay? for a number of reasons. But please do make sure your input and output format match the specification, because that's going to make it easier for you to see how you're going with the question. It's going to make it easier for us to see as well. So yeah, marks will be earned for correct code, not just passing the auto tests. So can I give you an example? I was going to show you this, but you can imagine a question that is, this isn't a question, by the way. Can you find this element in the linked list? Yes or no? Now, I could write a program that just returns no all the time, that doesn't do anything with the linked list, right? Return 0, that's it. How many auto tests would you expect that to pass? About 50%, right? And you've written no code. So sometimes, and that's the kind of extreme example, sometimes you might write something that does pass a few auto tests, and it's not because you've written the right code. It's just that you've happened to print out the right answer a few times for some other reason. Now, if you pass all of the questions and you've genuinely coded it up, I mean, all the auto tests, you can be confident. But if you're passing, say, 3 auto tests out of 10, you know, it might be a situation like that. And sometimes people then think, well, why didn't I get 30% of the marks? And it's not like that. We look at the code to check what you've done. And it can work the other way as well. You might pass no tests and we look at your code and think, oh, that was really good code, you just missed this. We're going to give you 7 out of 10 or 8 out of 10 or 6, but you know, you might get more when we look at it. Yep.
Suppose the auto tests aren't valid, you pass the auto test, but suppose there is audit nesting here and there in my program.
The question was, what if it passes the auto test, but I've got too much nesting? That's okay. So I'll talk about style in a minute. That's going to be okay. Also, just as like with a lot of the labs, we've got extra auto marking tests as well. So there could be edge cases that you didn't consider as well so you might, sometimes people say, I passed 100% of the auto tests, why didn't I get 100% of the marks? It doesn't necessarily work like that. The auto tests are a good indication, but they don't predict your exact mark. Exam marking and style. So there are no marks for style. You don't need to explain your code in comments, but if you make it really, really messy, you're going to confuse yourself and you'll find it difficult to debug it. So if you race in and you have a complicated program and you've just called all your integers A, B, C, D, E, F, G, you're quickly going to be really confused, and you're going to waste more time with your confusion than if you just breathed and put some good variable names in there. So for your sake, you know, have some indentation and some decent variable names. Also, we're hand marking it, so you might not pass all the auto tests, or even if you do, we might need to look through and see what your code's doing. And if we can't understand it because it's A, B, C, D, E, F, G, we might, not on purpose, we might not see the merit in what you've done, or if it's everywhere. So, you know, make it easy for you. That'll make it easy for us to mark as well. What should you study? People often ask this, but the whole course has been set up in a way where you've been studying the whole time, because every time you've sat down and done a lab, that's kind of studying because it's a practical exam. Every time you've sat there in front of, you know, lots of error messages, debugging them, that's studying. But yeah, the basics are important. You know, of course, you're going to have to know those basics we did back in week 1 or 2 to do anything. You definitely need to know linked lists and arrays because they're hurdles. You know, so just, I guess I would go back and do my problem sets again. And you might be really proud of yourself. That might make you feel good because you might go back to, say, something you did in week 3, which at the time you thought, you know, took you so long and it was so hard, and you might go back now and just do it more easily because you've had all of this experience. So it could really help, I don't know, it reminds you of things, it's a revision tool, and it can also give you some more confidence. hopefully. Revision exercises. There's lots of sort of resources to go back and try more coding. You can look at the lecture examples and try and code them yourself. Of course, try the week 10 practice exam. Oh, I've already said about the ChatGPT. It won't be in the exam. Yeah, stop using that in your studies. Okay. Oh, the other thing that happens, which can really stress people out and make them flustered at the beginning of the exam, is some people come in and don't know their ZID and ZPass and then proceed to panic, which I would 100% do too if I was in that situation. So make sure you know your ZID and ZPass, because you're not going to have your phone. Like if you've got the details in your phone, you don't have your phone to check what your password is. You need to know it. You don't have your laptop that you might log in and find it, or whatever you've usually got. So make sure you know your ZID and ZPass, because that will be stressful. All right, and I think Brianna mentioned this before. In that reading time, make use of it. Look through the questions, work out which ones you want to do first that you know you're good at. Try and pick the best 2 hurdles to start with and just get those out of the way. You know, plan it. You might, know one topic better than the other, so that might mean you don't do it in the exact order. The exact order is sort of meant to be sort of in a good order of easy to hard, but everyone's different. The other thing is, read the question properly and understand what you're trying to do. Lots of people in an exam might be half an hour into a question and realise, oh no, that's not what the question's asking. We don't want to do that. So try and make sure you've looked at all the input and output and know what you're doing before you rush in. Also, the question might say, you must not use string.h, or you must not use something or other. And you've sat there typing it out with that thing that you're not allowed to use. And then the auto test says, no, you're not allowed to use that. So just be careful of those things. Or you're not allowed to do a malloc in this question. Whatever it is, make sure you're following those instructions. Otherwise, you're going to get panicked when you suddenly realise that you weren't meant to use it. Yep.
Do we need to remember all the different libraries that we can use?
Do you need to remember all the different libraries you can use? There's going to be that cheat sheet, right? You know that cheat sheet? Let's have a look. Oh no, I know where to go. Where is it? Oh, important resources. So yeah, you'll have this cheat sheet, the C cheat sheet. So have a look at what's on that. You'll have these guides. The other thing, I don't know if anyone's ever used it. Has anyone heard of man? Yeah, you can type in man for things. Now, if you've never used man before, typing this in is probably going to confuse you more than anything. But if you are used to using man, you can still use man in the exam. If you don't panic and look at it. It might be confusing, I don't know. But you can do things like man, but that's all on the cheat sheet. That's all on the cheat sheet. Okay. But yeah, obviously you don't have time in the exam to look up all the different resources on everything. So you need to be familiar with the general sorts of things you might commonly use. That's going to be the best idea. Slide, okay, we'll have a break in a minute. Yeah, and prepare, especially with linked lists, but arrays as well, like maybe draw diagrams to help. It's very easy to be off by one with an index in an array. It's very easy to do, I don't know what with linked lists, so drawing the diagrams helps. The other thing is, there's a trade-off between spending too long on each question and not enough time. So you don't want to rush through and spend 5 minutes on each question just making a mess, not getting anywhere, and rush through the whole exam like that, and you've actually not completed any questions because you're just panicking and going, I don't know, I better start the next one. But then you don't also want to be stuck on one of those debugging questions and you realize, oops, I've just spent 2 hours, I still don't know how to fix it, and there's other questions I could have done, you know? So just be aware of your exam technique and time management. It's easy to get lost in debugging and lose track of the time. But yeah, try and definitely focus on getting some of those hurdles out and spending some decent time on those. All right. Now, this is we've talked about exams. It might be a bit stressful. This is a beautiful, cute little baby sloth. So think about this little baby and how cute it is. And how, you know, there is more to life than just this exam mark or any of your exam marks, right? And more to you as people. So try and get a good night's sleep. This, I know I sound like I'm trying to be a mum now, right? I'm mum to a cat who definitely doesn't sleep well. Try and eat properly before so you can concentrate. Yeah, make sure you can breathe, you can do it. But yeah, definitely the sleep and the eating well. I never did either of those two things. So I was always like tired and a mess. I'd eaten like a Mars bar or something for breakfast and some Coca-Cola. I don't drink Coca-Cola anymore. Hadn't slept much. Yeah, it's not good. So your health is very important, right? You've got more than one exam, blah, blah, blah. All right, we'll have a break. We'll come back at about 5 past. We'll do those hurdles. We'll probably do a Kahoot. We'll do some stuff that we didn't finish last time, depending on how we go for time. And we'll do a poll of the most important topics you want to revise next week. So whatever, yeah. So let's come back at 5 past. All right, so we're going to look at some of these hurdle questions. So the first one is largest. Now, you know, this is kind of the style of thing you might get, where you have to do one function, and we might give you some test code, And usually you'd have the whole question explaining exactly how to compile it and run it and that sort of thing, what input and output to expect. I haven't written that all up, I'll just talk us through it. But yeah, I mean, also don't forget to get rid of these returns that we've put in. Don't accidentally do something like this, forget it's there and write your other code. Like I've done that myself before. Urgh. And then I'm getting weird compiler messages. All right, how do we find the largest node or largest value in a linked list? So maybe if I've got, I won't draw the exact same list. Null. Head. All right, I've got a list like that. How do I find the largest one? What are our ideas? Yeah, current. We've got, and when I hear the word current, I'm thinking, yeah, some kind of traversal is like usually what we kind of mean. So we should sort of have an idea that we're going to do something like struct node current equals head, and we're probably going to have some while loop because we want to go through every single node because any of those nodes could be the biggest one, right? So we'd have to have while current, what would be our stopping condition? Yeah, not equal to null. I want to go through every single node. I don't want to stop at the last node. I want to keep going. So to do the traversal, I'm always going to do something like this, right? But then what else am I doing?
We'll start with our max, which will have current later.
Yeah, so we need some kind of max. Now, do we keep track of the maximum node, the maximum value? For this one, we can just keep track of the maximum value, right? We don't need the whole node. And what do I initialize it to be? Yeah, I'd probably want to initialize it to be the first thing in the list. All right, so already we can see a potential issue, right? Even if we can't, let's keep going, we'll come back. Now, what are we doing for every node? So right now, if we look through it, we've got our max value equals 3. Right, our current value is 3, our max value is 3. We're going to go through the list and we don't care that we're checking the first node again and we know that that's already the max value so far. We don't have to make this super efficient. But as we're going along and checking it, what are we doing? How do we check? So I'm checking whether the data in my current node is greater than the max value I've seen so far. Yep. So in this case, if current is up to 4, 4 is greater than 3. So actually now that's the biggest value we've seen so far. So I want to update it and say max value equals current data. So now my max value is 4. As I go through the list, I move it to the next one. And we'll be comparing current data, which is 6. That's greater than 4. So now our max value is 6. We move current to current next. And we check, is 5 greater than 6? Is this 5 here greater than this max value? No. So we don't update it. We don't do anything. We just move current to current next. Current is now null. And the loop is finished. And now what do I do? Yeah, return max value, that's right. Now, when we do this, I mean, in the exam as well, I mean, most of you might just start running the auto tests. That's great when they all pass. When they don't, sometimes you need to go and compile it. Or if you want to test it yourself, you might want to compile it. a lot of these linked list questions will allow you to type the linked list on the command line. You would have seen this in some labs as well. And the actual exam would instruct you how to do this. So we'd think that we're going to get 6 for this, right? And we do. And if we put the 6 somewhere else, or the biggest one somewhere else, we get 6. What about if it was at the beginning? What if it was the only node? Now, what are we expecting will happen if we do with an empty list? Yeah, it's going to crash. Why? And actually this line here, we've got this line here that we don't always have. As soon as we've got current arrow something, the first current arrow something, if it's null, is going to crash it. So let's crash it. Let me just compile it again because I've sort of changed stuff. Yeah, it's crashing on this line. So we would need to have a special case for the head. If the head's null, and this is really going to depend on what the question's asking. The question would need to tell us either return -1 if the list is empty. I don't know. Don't test it if it's empty. We won't test it on that. But you need to think about it. Let's pretend the question said return -1. Okay. So this is kind of one sort of way you could pass a linked list hurdle, by doing something like this. Any questions? All right, what about difference? So everyone just take a minute or so to think about this and think about what you're going to do to write code for this. Not necessarily every line of code, but how you're going to approach this.
Can you just run 2 counters going through what they call it, what is it? Going through the struct, going through doing this, and then after that we compare it again. Like just how we,
Yeah, so the is that what everyone's thinking? We've just got to run through and do counters on both lists, right? Now, do we do it first for the first list and then second for the second list, or do we have to do them both at the same time? Well, yeah, they're probably not the same length, so it's going to be easier to find how many nodes are in the first list, then how many nodes are in the second list, and there's no interaction between those sort of outcomes. Sometimes you might need to loop through them both at the same time if you are comparing, I don't know, do these lists have equal values? You might need to go through them both at the same time and compare the corresponding values. But here we just want to know, first of all, how many nodes are in each list. And lots of people kind of don't like making extra functions. I don't know why, but I would. Oh, try and do it. I'd try and write a size function. So if I've got a list, and I want to find the size of it, how do I do that? I do some kind of traversal with current, and I move it along one by one until I get to the end. So I do something like this. But yeah, I also have to take into account, you know, what I'm trying to do, which is find the number of nodes in this list. So I'm going to have a counter, and I need to initialize it to 0. And every time I go through this loop, that's another node in my list. So I just say something like this. And at the end, I return the number of nodes. So we've kind of seen exactly this kind of code before to find the number of nodes or size of a list. Is everyone sort of okay with this function here? Now, if that works, then I could use this to solve the rest of the question, which is basically I want to find the size of the first list. I want to find the size of the second list. And then I want to find the difference. Except it's not quite that simple, right? So if we look at the example, if I do this, let me just do it. I found the size of the two lists. I've done my subtraction. I'm going to compile it and run it. Oops. Oh. Now when we run this, typically the way it's set up when we do this on the command line with more than one linked list, we usually put a dash between it to indicate the next linked list. Again, the question would tell you this. So here we're going to have 3 in one list and 5 in the other. And ours is going to give us -2. And the answer is saying, imagine this is the exam question, 2. So what do we need to do? Yeah, I heard absolute value. How do I do absolute value? Yeah, someone's saying ABS. There's actually a function. Yeah, there's actually an abs function. So I could return the absolute value. Oh. And I believe it's in stdlib, which is already included here. Right? Now, if you didn't know that, are you doomed? Because you forgot that that absolute value library existed, you never knew it existed, are you doomed? No. You could just do an if statement, you know, if diff is less than 0, diff equals minus diff, or -1 times diff, or you could have if size 1 is greater than size 2, diff equals size 1 minus. You can, you know, do it however you like. But yeah, so that's that extra problem solving step. How are we going to approach it? But it's not, it's very close to things we've seen before. Any questions about that? All right, let's have a look at direction. Now, how's everyone feeling about arrays of structs? So we've got some kind of an array of structs here, and in our array, each struct has a number of steps and a direction. That's an L, by the way. Let me draw it like that, maybe. Right, so it might have an array of structs. They've all got a number of steps and a direction like R, L. It doesn't say what else it could be. Up, down, I don't know. That's our array. We know the size of it. And we want to find all of the ones that have a direction of L, and we want to add up all the steps, the numbers of steps. So we're going to need something like total step counter. I'll put that as 0. Now, what's the standard way of just looking through a whole array? Yeah, this is like our traversal of an array. I have some kind of I is less than size, I++. So this is going to give us index 0, 1, 2, 3 in this situation. Now, everyone's been used to using pointers to structs recently, probably, but we don't have pointers here. We've just got an array of structs. So what am I going to do? What's my next step? I'm trying to go through each one. What am I doing for each one? So I can access the kind of data inside this by saying array I, and that gives me the whole struct, whoops. And if I want, we're looking here for the direction. If I want the direction field, I use dot. So don't forget about dot. Now, I'm basically checking. I want to check if this is equal to L. And remember, this is one character. Oops. This is one character. It's not a string that we're comparing it to. I can use equals equals. I use single quotes. So if this is equal to L, I want to go and get the number out of this struct. And add it onto my total. Then at the end, I return the total step. Does this look right? Now, is there anything in there that you forgot about or never knew, or any questions? I mean, does it work though? Listen to me. All right, let's compile it. Now there's some main function code down here. If you're looking at this and panicking, thinking, what does that mean? I've never seen it before. First of all, have you ever seen it before? All right. So it doesn't matter, you won't be expected to do this, but you know how we use the brackets, the curly brackets to initialize an array? That's what we're doing here. And we're kind of putting the struct values in here as well, we're labeling them. So you're not expected to have memorized this syntax. Oh, I haven't called the function yet. This is the main here. So this is setting up an array of structs. So if you see this in the exam, all it's doing is setting up an array of structs. You're not expected to know how to write this code, but it might be in the test code. It's setting up, and you might want to modify it to test different things. So it's setting up an array. What are we expecting when it does call it? It's passing this array in. What answer are we expecting this to print out? So yeah, this is a struct with a direction of L. This has a direction U, D, U. So we'd expect it to add up the 3 and the 5. Let's see if we get 8. Yeah, we do. Now, if we wanted to change this and see, you know, does it work in other situations, we can. We can modify this and check that we're getting the right answer. All right, one last hurdle question. So everyone just, I'm not even going to write anything. Try and write this in your head or on your computer or on a piece of paper. Oh, the question. You're just finding all the elements in that array that are divisible by 3. Okay? And so remember, someone online's asking, yeah, we use arrows if we've got a pointer to an array, a pointer to a struct, and we use dot if we've just got a struct. Yeah. All right, let's count multiples. So again, this is like we're traversing through an array. We're looking at every single element in that array, and we're checking every single element to see if it's divisible by 3. So I need, and I'm counting something. I know I'm going to initialize that to 0. But then I've got my kind of standard, let's go through every array one by one thing. So if you get good at sort of not typing this in, but realizing this is what you have to type in, that's going to help you. Now, we're checking everything. We're checking every element in the array. So we're going to have an if statement. So for every element in the array at index I, we're just checking if it's, what are we checking? And I check that by, mod, if mod 3 equals 0. So by the time people get to the exam, sometimes they've forgotten about mod because everyone's been doing linked lists and stuff like that. And then they're in the exam and they're like thinking, oh my goodness, and they blank. So remember that, mod will do the remainder. If that's equal to 0, something's divisible. Yeah, counter plus plus. If not, keep going. And then at the end, I return counter. Is that it? And down the bottom, again, I've been given test code. Often you may not even run that test code because you might be just using the auto tests, but sometimes, especially if your code isn't working or you've got more time to check it, you might want to go and check it. So we got 3. Is that correct? Yep, let's just check that we're not just accidentally printing out 3 a few times. Okay. All right. Now, any questions about those 4 hurdles we've looked at? Who's feeling good about those initial hurdles, or who's feeling okay? I'm sure no one's feeling elated or excited, but who's feeling okay-ish? Okay. Now, imagine I'm in the exam. Well, I don't want to traumatize you too much, but this is a common mistake that people do that I've marked before, right? So this is finding the largest value in a linked list. What have I done wrong? Yeah, look, when people are rushing, especially if their indentation's not good, they can put this thing inside an if statement or something, and they can end up in some kind of infinite loop because it's not progressing. It's stuck in there. Just be careful of things like that. That's a really common mistake, more so than forgetting to have that line of code at all. All right, has anyone got questions before we do a Kahoot? All right, we'll do a revision Kahoot. Just to remind you of some of the stuff that potentially can come up. And yeah, just a reminder, to get examples of what might be 2-dot hurdles and questions, debugging questions, questions 9, 10, and 11, you're going to have the whole practice exam to look at. And we are going to do more revision next week as well. I'll just give everyone like another minute or so to join. Okay. All right, let's let's start. If anyone's thinking what's F puts, it's just the same as printf %s. Okay, yeah, this is a mean, tricky question. I think I got this wrong last term when I was doing it, when Jake ran this question, because I didn't read it properly, but you've got a ticking clock, right? Now, F-puts, you don't have to ever really use F-puts in this course. You can always use printf %s, so don't worry if you weren't sure what that was. Why did it not print out this as a string? Yeah, the size was 5. The size of our string was 5. We use fgets. Fgets is a responsible string user and will chop off the stuff that doesn't fit. So you're going to get TIHS, and then it's not even going to read the space because it's got size 5 and it knows it has to put a null terminator in there. So these are the sorts of things we start forgetting when we're kind of just doing other things a lot, right? Okay, any other questions about that? Yeah, and I didn't look and I just thought, yeah, this is a string. Okay. So basically, what would be in these arrays? Or this array? Oh, cool. So yeah, again, this is a sort of specific detail that people might forget. But as soon as you initialize anything in these brackets, anything that hasn't been given a value will be set to 0 automatically. So this will fill the whole thing up with zeros. And in fact, I believe even if you don't put a 0 in there, because you've got the brackets, it'll fill everything up with zeros. So it will have all zeros. The 3 arrays of size 3, again, that's another issue. We've got 3 rows, 3 columns in this. They're all going to be zeros. So what, again, maybe I should have added extra seconds to these. This is like a speed reading code course, isn't it? With like distractor music on. Okay. So we've got A, which has 10 in it. B has 20. This pointer is pointing to A. Has the address of A in it. If I say star pointer, well, star pointer actually takes me to this location here. If I say that equals B, it's sticking the value of 20 in here. So is everyone happy with that? Then when we print out A, it has the value 20 in it. So does anyone have any questions about that? At high speed, you're going to get stuff like that wrong, but if you know, there's some fundamental sort of skills or, I don't know, concepts that you have a question about, please let me know. All right. Agile bear. Yeah, this one has lots of seconds. What does this mean? I don't know. So 43 got it right and 28 didn't, but I don't know what. Anyway, so this is the order. Does everyone agree? So yeah, we've got temp. So if we've got, let's just run through it to check it's correct. I've got 3 in here for A, 5 in here for B. I created temp and I put the value of A in there. I say A equals B, so I'm overwriting this value of A. Oh gosh, I'm making a mess. I'll overwrite this value of A with 5, which is why I put it in temp. Then I say B equals temp, putting the 3 in there. Yeah, cool. All right, let's keep going. Wow, amazing. Next. Now you might be doing a lot of this at the moment. Okay, cool. Amazing eagle. So yeah, what size are we printing? Size of struct node star. What is struct node star? It's actually that type is like an address, like a pointer. So this type is big enough to store an address. Now the problem is if you're doing a malloc with your linked list and you do something like this, you're going to get 8 bytes instead of enough bytes to store everything you need to in the struct. So in this example, gosh, we'd need at least 40 bytes for the whole struct. If you do your malloc using this kind of size of, you're not going to get enough memory. Has anyone done that accidentally? No? Often people do it. All right. Okay, now here are some hard ones. I'll be quiet. Okay, so why did we get 4? Yeah, so this code almost looks like the code we just wrote before to find the length of a list. We're traversing it, we're doing I++, except we're stopping at the last node. So we're counting the node 3, 5, 6, 7. We're stopping with 8. We don't do that increment. So it's finding the length of the list minus 1, this code. And again, that can be a common mistake too, doing that kind of thing. Yep, runtime error. This is the same code, but we've got an empty list. And anytime we've got current arrow anything or anything arrow anything and it's null, it should be screaming runtime error. Last question. Wow. Yeah, I thought that was a bit of a tricky, nasty one, really. What's going on in this one? So when we finish the loop, we're going to current next is equal to null. So obviously if we run this with an empty list, it'll crash. If we run it with a list with one thing in it, it'll crash. But otherwise in this list, we're not going up to the last one, we're going up to the second last one, right? So current will be here. Boo is current next. Is this correct? Tell me if I'm doing it wrong. Then I'm saying current next equals null. So I'm cutting off the rest of this list. And then I'm freeing boo. Yeah. Weird code would be buggy and crash in other situations. Okay, that's the Kahoot. So again, we've just got some chocolates again. If you're in the room and you're silver lobster, or you're smiling lobster, or you're what other lobster do we have? Speedy cheetah. If you're in the room, put your hand up, you can get chocolates. Whether you're in the room or not, well done. Oh, and the runners up. If you're the runners up, put your hand up too. Amazon something and something. I don't know. All right. While we're doing that, we're not going to have time to do a code example, but what I want to do is just so next week we're going to be doing a lot of revision. And I just want to see if there's any topic that stands out that lots of people really want to focus on. So the next lecture will be all revision. The last lecture on the last day will be mostly revision, but in the last half hour, we're going to have some of the tutors come up and talk, give, I don't know, advice about the exam, advice about what subjects to choose next term, internships, I don't know, whatever kind of stuff you're interested in. So that will be the last lecture, just the last half hour, but everything else will be revision. So this Kahoot is just to find out what people's main topics are so I can focus on them. I'll revise pretty much everything anyway, but if there's something that lots of people really want, then we can cover that. The other thing is, while I'm just sitting here waiting for people to join, if you're really struggling with assignment 2 and you can't even get started because, you know, you're just overwhelmed, you just don't know where to begin, please let us know. Come to help sessions, email us and let us know, and we can try and help you. All right. And if there's anything on that you really want to do that's not on this list, just come and tell me at the end. Let's start. Actually, if there's other topics, feel free just to call them out or put them in the chat that I haven't thought of that you really are desperate to find out more about. Okay. So a big topic is command line arguments and strings. So we'll definitely go over examples of that, hurdles and harder linked lists. They're the kind of big 3. All right, we'll do some of the others as well, but I'll focus on those. All right, call out if there's something else. We'll leave it here for today. Next week's all revision. Please, start practicing not using ChatGPT if you've been using it too much. Let us know if you need help with the assignment or there's something happening. We're here to help you all. Okay, see you next week. See you later.